In question number 16, we're asked, which of the following motions must have always a zero acceleration? And so we're given three choices: any motion in a straight line, simple harmonic motion, which comes later on in this course, so you don't really know anything about. Most of you might have, or were probably thinking, I don't know what simple harmonic oscillation is. By the way, just so you know, simple harmonic oscillation is motion that is repeatable and follows a sine or a cosine function. A good example of something that's a simple harmonic oscillator would be a mass attached to a spring. And so we have some sort of a spring attached to the wall with some constant of elasticity K, and this mass that I'm kind of drawing in the solid blue color is going to start there, and then, let's call that position 0, and then something or someone comes along and displaces the mass off to the right-hand side. So let's just zoom in on that. And it's going to wiggle back and forth. We're going to call that maximum displacement its amplitude, and we're going to say that it's going to also have a negative amplitude. And it's basically going to wiggle back and forth, and it's going to make essentially a sine function. So it's continuously getting faster and slower during the simple harmonic motion. And so if it's getting faster and slower, then that is a non-zero acceleration. That's a changing acceleration, actually. And so choice number 2 can't be one of our answers because it's accelerating. Motion in a straight line, we've seen motion in a straight line quite a bit in Unit 1 kinematics, and we've seen constant motion that does have zero motion, but we've also seen, accelerated motion in a straight line. A roller skater attaches a rocket to their back, and they're going to accelerate. So choice number 1's not a good choice because we have seen already that can happen. Circular motion is a bit tricky. Something can be moving in circular motion. Newton's first law says that an object in motion will stay in motion in a straight line if the net external force is 0. This is the direction of velocity, and at some later time, let's call that initial time, time 1, at some later time, the direction of velocity has changed. Notice, again, that the magnitude of velocity hasn't changed at time 2, but the direction has. And so, therefore, there is this part of velocity being a vector. Its direction has changed, and therefore it is accelerated. We'll find out in Unit 3 that the direction of acceleration is always radially inward or perpendicular to the direction of velocity. So we can see that choice 3 is also incorrect, which is why our answer for question number 16 is E. None of these guarantees zero acceleration.